this lesson is going to have a look at completing a square. It is something that often seems to get neglected a bit when you come across it in quadratics. And then by the time you get to function, it's like, oh my word, now there's something I should have done with this. Let me go back and revise it. So it'd be a much better plan if you get really familiar with completing the square before you end up in functions. So let's get it sorted now as one of these starting points of skills. So completing the square. We're actually going to start out with why we use this format and where it comes in so very useful. So the format is P x plus q all squared plus r. So in some cases you will see this written as a x plus b all squared plus c. But the reason why I use the P, Q, and R is because so many people get stuck with the other ax squared plus bx plus c. This is your standard quadratic format. These are not the same a, b, and c's. Okay, so this is actually often how they put it in your exam papers. But it's a very different A, B, and C. You can't just take that A and put in there, take that B and put in there, and take that C and put in there. It doesn't work like that. Okay, so the PQR is a reminder that we have to calculate these different coefficients, these different values. So this is what the format looks like. What are we using it for? The big thing is understanding our quadratics. So if we have a quadratic, remember we have either a happy face or a sad face. Okay, each of those has a vertex, also known as a stationary point, also known as, in this case, a minimum. Minimum helps if you spell it right. And in the case on the right-hand side, we have a maximum. Now, what is so beautifully wonderful about this completed square format is that we can get the coordinates of that vertex without doing a single calculation. All we have to do is change the sign of the one in the brackets, so we would have minus q, and keep the sign of the one outside the brackets, and we have r. So when we have completed square format, we have the coordinates of that vertex. And we're going to take that just to sketch our curves. We're going to use that when we're doing the range and domain with a quadratic. And it's just one of those, once you know where the curve is sitting, then you have a whole lot more power and understanding over that curve. So stationary point is one of the major things. Okay, also obviously if you've got the x-coordinate of the vertex, you've got the line of symmetry of that graph as well, because x equals minus q is going to cut that graph precisely in half. Now a couple of things where this is going to come up and save your life is when we do inverse of a quadratic, you must be in completed square format in order to be able to do the inverse of a quadratic. When we do transformation of functions, there is some very, very cool things going on there. It's going to link straight back to completed square format. And the other one is when we look at gradient of a function. So when we have a curved function and we're getting into calculus, we're going to play with where we have positive and negative gradients. And the only way to do that if you have a quadratic gradient is to use completed square format. So this isn't just a case of know how to complete the square. Oh, yay, I can do it. We're actually going to use this skill in quite a lot of other places in the course. So we're building a skill which is going to take us further. So it is a really important one. It is worthwhile learning how to do, and it is worthwhile taking the practice and doing 50 of them if you have to in order to get this sorted. So now we've got the context of why we do it, let's talk about how we do it. We're going to start with x squared plus bx plus c. Okay, we're not working here with a coefficient of x squared other than 1. So we have just one x squared, so plain old x squared. Here's our simpler format, so we'll start with him. Also note, this is not solving an equation at this stage. This is just algebraic manipulation. We're just going to take that quadratic as it's written there, and we're going to rewrite it in another way for all sorts of fun reasons, as we've just seen. So if we take this and we say, okay, I want to complete the square. Now, there are various different ways to do this. There's some ways taught in different textbooks have different ways, different teachers have different ways. So if you have a method that works for you, fantastic, go ahead and use it. If you don't have a method already that works, or if you're not happy with your current method, have a look at this method. So we learn the little song that x plus a half b all squared minus a quarter b squared plus c is going to give us our completed square format. That is how we now take our coefficients, our b and our c, and turn them into a completed square format. Okay, it's a little bit theoretical, so let us put it into a few examples so you can see how it's really happening. So for example, x squared plus 4x plus 1. Now, bear in mind that as you go through this, when you start out, you might want to put out lots and lots of intermediate steps, okay? But where we're aiming for is not writing out the basics, okay? It's just those steps that we need to in order to get through safely. So, x squared plus 4x plus 1, coefficient of x squared is 1, we can go straight into our lovely formula. So, x plus a half b, so plus a half times 4 plus 2, all squared, minus a quarter b squared, 4 squared is 16 plus c plus 1. So you have x plus 2 all squared minus 16 over 4, well 16 divided by 4 is 4, so minus 4 plus 1 is minus 3. Done. Okay, and from there, let's go straight with our vertex. We can see, remember, we changed the sign of the one inside, and we keep the sign of the one outside. So minus 2, minus 3 is our vertex. We see he's a happy quadratic, so we could even go so far already as to know our quadratic is sitting somewhere down here. Minus 2, minus 3. So we're building that understanding. We're getting to know the quadratic. The hot spot on this one always is this minus sign. Remember, it's minus a quarter b squared plus c, but then also when you do a calculation, it is a minus here and then a plus. So don't forget, or don't leave out, or don't skip over that minus sign. Let's do another one. X squared minus 6x plus 5. So we're going to do exactly the same thing. X plus a half b. Well, a half times minus 6 gives us minus 3. All squared minus a quarter b squared. Minus 6 squared is minus 6 times minus 6 is plus 36. So you see, this term is still going to be a minus term, even though our b is minus. As soon as we square it, we get rid of that negative. Plus c is plus 5. So here we have x minus 3, all squared. 36 divided by 4 is 9. So minus 9 plus 5 is minus 4. And of course, why not? Vertex is going to be minus 3 becomes 3, minus 4 stays minus 4. So we've gone from just an x squared minus 6x plus 5, hoorah, you know, great, we've got a quadratic, to a format which we can use for so many other things and immediately knowing exactly where that vertex is going to fall. One more because we've got the space for it, and it's always good to do lots of practice for maths. X squared plus 8x minus 1. Exactly the same thing. And this is why it's worthwhile doing 20 of these or 30 of these, because by the time you've done that many, you've really got a very good idea of what is going on. And you'll have learned this formula. So, x plus a half times b, a half times 8 is plus 4, all squared, minus a quarter, b squared, 8 squared is 64, I believe. It is, minus 1. Okay, so minus 64 over 4 minus 1. So 64 over 4. That gives us x plus 4 all squared minus 17. So note, in this case, we had our minus and a minus again. So we have minus 16, minus 17. Minus 16 minus 1 gives us minus 17. And again, for the fun of it, our vertex is x plus 4 all squared. What am I doing? And that was our completed square format. Our vertex is change the sign, keep the sign. So here's another one for you. What's the minimum value of this quadratic? Okay, so now you got to think nicely. Right, so what is the smallest value my quadratic could be? So we're going to be thinking about what is the smallest y value. So remember, if we sketch, if we have a happy quadratic, there's our vertex, minus 4, minus 17. And remember we said when we have a vertex that's down here on the bottom, it's called a minimum. So it's always an output value, so we're always looking at what would our y value be. So our y value is our minimum value in this case, so it would be minus 17. If we had a sad quadratic, we would have a maximum value that our quadratic can take. But in this case, it's a minimum value. So there's little things that we can tie onto here to make our understanding of this quadratic even more intense. We don't just stop at understanding the vertex. And we're going to build on that and develop that further when we get into really looking at functions. So hopefully now you've got a good understanding of what happens when we've got x squared plus bx plus c. Now we need to say, okay, well, let's step it up. What happens if we have ax squared and that a is something other than a 1? So if we have ax squared plus bx plus c, how do we complete the square on this? Well, I'm afraid that all we do is we get rid of that a. So we take him out. X squared plus b over a x plus c over a. Then we're going to complete the square on our normal plain quadratic on the inside, and then we can multiply our a back in. So, for example, if we actually do this, we would have a on the outside. We would have x plus a half times b over a, all squared, minus a quarter b over a squared, plus c over a. This is looking ugly. So, if we then bring our a back in, we would have a x plus b over 2a squared minus b squared over 4a, because one of them is going to cancel there, plus the A is going to cancel with that one under the C, so C. Now that looks ugly. Now to remember that is just horribleness. So you are not expected to remember that. You can do it just on the basis of take the A out, complete the square, bring the A back in. So let's have a look at what that actually looks like when we do it. So for example, we have 2x squared minus 4x plus 9. Okay, so first thing, get that A out. So 2x squared minus 4 divided by 2 is 2x plus 9 over 2. Leave it in a fraction. Fractions are your friends. You love fractions. You work with fractions. Okay, so 2. Now we can complete the square on this plain quadratic on the inside. So x plus a half b, x minus 1, all squared, minus a quarter, b squared is 4 plus c. So 2x minus 1 all squared minus 1 plus 9 over 2 is 7 over 2. If you are in the slightest bit unhappy about fractions or anything like that, use your calculator. Just make sure you put your signs in properly. Now when we multiply that 2 back in, we'd have 2 times the bracket, so 2x minus 1 all squared plus 2 times 7 over 2 plus 7. So you see why it's nice to do it as a fraction? The fractions just poof, disappear. And now we have completed square format, 2 times x minus 1 all squared plus 7. And just because there's an A there, doesn't do anything to our vertex. Our vertex is still, change the sign, keep the sign. Finished. So the vertex of 2x squared minus 4x plus 9 is 1, 7. We can do exactly the same thing with another quadratic. And here's one that maybe was missing from before. Minus x squared minus 2x minus 6. So all the quadratics we did previously, when we did x squared plus bx plus c, they were all happy quadratics. Because remember we said for x squared plus bx plus c, the coefficient of x is 1. Minus 1 is not 1. Minus 1 is a whole different kettle of fish. So him, you must do like this. You must take that minus 1 out. So minus x squared plus 2x plus 6, because we must take that minus out from every single term. Now we complete the square on our 1 inside the square bracket. So minus x plus a half b plus 1, all squared, minus a quarter. B squared is now 4 again, plus c, close. So minus x plus 1 all squared minus 1 plus 6 is plus 5. Then we bring that minus in again on both terms. So minus x plus 1 all squared minus 5. And again, vertex works exactly the same. Okay, so change the sign, keep the sign, but in this case, because this is a sad curve, we now have a maximum. Okay, because our curve is a sad face, it's a negative x squared, so our vertex sits at the top. It's a maximum point. Okay, one more, we've got the space, and it's always good to do the practice. So 2x squared minus x minus 2. A lot more negatives going on here, so it's important to keep your eye on that. Signs are so important, and they can cause problems so quickly. So 2x squared, we've got to get rid of that 2. 2x squared minus a half x, because remember there's a 1 sitting in here, minus 1. So we're stepping it up with our fractions here. 2 square brackets, x plus a half b. So x minus a half times a half is a quarter, all squared, minus a quarter, b squared, So we're going to have to write this differently. We're not going to double stack our fractions just for the fun of it. B squared, a half times a half is a quarter. Minus 1. So we have 2. We have x minus a quarter, all squared. We have minus 1 over 16 minus 1, giving us minus 17 over 16. Again, a reminder, if you're going to plug them into your calculator, make sure you plug with the signs and be careful of things like that. Okay, bringing our 2 back in on both of them, then we have 2x minus a quarter, all squared, minus 17 over 8. And it is as ugly as that. You can have your fractions. Okay, but leave them as fractions. Don't turn them into mixed numbers and things like that, because when we're working with them further, then mixed numbers just cause problems in calculations. So in this case, we would leave it with our improper fraction of 17 over 8, and we would, again, just give a vertex if we were asked for it. We don't always give that vertex. It's just a nice reminder here, because this is what you're building on as you get started. It's what the point of completing the square? Well, it's all about the vertex. But remember that we're taking that vertex into somewhere else. Okay, we're taking it into an understanding of what our quadratic curve really looks like, so that we can then do other things with it, and we can understand it in a different way once we get to functions.